So lesson 1 starts on pages 9 through 11. Batters can't handle the heat. So students will be looking at modeling linear data and the meaning of the different parts of a function. There is an optional video to show students before starting this activity. The video looks at the math behind how fast a human body can pitch a fastball. And so there is some interesting information there. However, the video is very long. So we do recommend that you preview the video ahead of time to make sure that it is appropriate for your lesson and your students. This activity could be great as a partner activity, and you could also easily put this on Desmos if you're needing a virtual option instead of having your students do a worksheet. There we go. So then moving on to lesson 2, Scott's workout. The launch starts with this image, and this launch starts on page 13 and 14 if you're following along with us. So we recommend just starting with this image and just letting students take a moment and just kind of observe what they're seeing and start processing what is happening with the image. And then start posing some questions to students. So maybe start with, what do you notice about the pattern? So if you want to take a moment and in the chat, what do you notice about this pattern that you are seeing? Okay, a lot of people are saying that it's growing by 2 boxes. Somebody said it's starting with 3. Another person says it is linear. Another person says it is increasing at the same rate. So you can see that there's lots of different entry points here. You can tell a lot from a student based off of the vocabulary that they are using, how deep their understanding is. And so then another question might be, so what would be a good starting value to this problem when modeling it with a recursive function? So take a moment and think about that and put something in the chat. A lot of people saying 1. So you can see that without having any context whatsoever, just looking at the diagram, you're already gathering so much information about your students, and you're giving students a chance to really start looking at this and diving into it. And so from there, now that they've had a chance to really look at this image, now you can give them the context and the problem or what the question is asking behind this diagram. So this is another one that you could easily put on Desmos. You could have students work in pairs and have them create a Jamboard or a Google slide showing the thinking behind this problem. So there's lots of different options with this activity in order to make it work virtually. So lesson 3, working out with equations. So kind of the same idea here that we were exploring with lesson 2 there is just taking a piece of this activity out as your launch. So giving the context of the situation without any question as to what the problem is going to be asking. So it allows them to just digest what is going on in this situation. And this is one that could easily be turned into a numberless word problem. And there's lots of information out there on the internet about how numberless word problems work if you want to explore that further. And from there, you can again start asking them some questions. So what if she wanted to increase the number of calories she burns? What is she going to need to do? So you're starting to get kids thinking about the different context here. How might you model her calorie burning increasing in an equation? So now that you've thought about what she needs to do to increase that calorie burn, now how are we going to model that within an equation? And so once you get kids thinking about that, now go ahead and present the entire activity. Some things that you're going to want to keep in mind when going through this one is as you're having students do share outs, you really want to be focusing in on their ideas around equations. There's several different types of equations that are introduced or talked about within this lesson. So you're also going to want to pay special attention to making those connections between your A, B, and M variables in those various equations. And we do call that out in the teacher materials as well.